Hey everyone, so we are going to continue factoring our trinomials, and then we're going to learn the actual easiest of all the factoring methods today. All right, so pause the video and do the do now. So number one is a GCF. There's x's everywhere, and we know that we can divide by 4. So my GCF is 4x, 4x. We divide, we get 3x plus 8 divided by 4 is 2. And remember, those x's cancel out. Parentheses, 4x on the outside. Number 2, that's a trinomial, nothing in front of x squared. That tells us we're going to do our multiply combine chart. We're multiplying to negative 40, combining to positive 18. So I'm going to write down everything that multiplies to 40. 1 times 40, 2 times 20, 3 doesn't go into 40, 4 times 10, and 5 times 8. Now, since we're multiplying to a negative, one of our numbers needs to be negative. Since we're combining to a positive, we know it's the smaller one, so that when we combine those together, it's a positive number. It's positive 39, 18, 6, and 3. So I'm looking for my 18, and I have negative 2 and 20. So that gives me the inside of my parentheses. So whenever I have a trinomial like that, it's x times x. That gives us our x squared minus 2 and plus 20. And that's it. All right, so here are 4 more review problems. I want you to pause the video and try these on your own. So number 1, notice that it doesn't have that C term. So this is a GCF again. What can we divide into both of those? X divided by x is x plus 5. Parentheses, x on the outside. Now, if you notice, number 2 and number 4 are very, very similar. So I'm going to do those last. Number 3, we are multiplying to negative 72. This one tends to mess kids up. What are we combining to? It's always the coefficient, right? In number 2 and 4, we're combining to 17. This one, what's the invisible number in front of x? Remember, there's really a 1 there, so it's a negative 1. There are a lot of numbers that multiply to 72, but the answer is actually 8 and 9. Now, who's going to be negative? The 9 is negative to give us a negative 1. If you switch it, you'd have a positive 1. So x plus 8 and x minus 9. All right, so I'm going to write on the side, I'm going to do the same chart for both of these. So we have 60 and 17. All right, so we got 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10. All right, so now let's look at the top one first to start with. In this one, we have a negative 60. That means I have a negative 60, negative 17. I'm multiplying to a negative. When you multiply to a negative, you need a negative in the problem. So I'm going to make the bigger number negative in all of these. So now remember, when you have different signs, you subtract, right? Same sign, add and keep, different sign, subtract. So we are subtracting. Which of these subtracts to 17? Negative 59, negative 28, negative 17. We are subtracting to 17. Negative 11, negative 7, negative 4. So we get x plus 3, x minus 20. That's different than in number 4. In number 4, we're multiplying to a positive 60. When you multiply to a positive, it has to be the same sign. They're either both positive or both negative. Since we're combining to a negative, right, a negative 17, we know it has to be x minus, x minus. So this time, when they have to be the same sign, and that means we're adding. Same sign, add, and keep. Same sign, we add, and we keep the sign the same. All right, so now, in this case, everything has to be negative. So now when I add across, negative 61, negative 32, negative 23. That's not what I want, right? Before it was the 3 and the 20. That doesn't work. Negative 19, negative 17. So this time, it's the 5 and the 12. So look how similar those two problems are, but the answers are incredibly different. So you have to pay attention to the signs. That's the most difficult part of this, is watch your signs. All right, here are two more. Same idea as that last slide. So we're multiplying to 24, combining to 10, but watch the signs. The answers are going to be very, very different. So here I have x and x, x and x. So we are multiplying to 24, combining to 10. So 24 is 1 times 24, 2 times 12, 3 times 8, and 4 times 6. All right, so now the one on the left, I have a negative. So we're multiplying to a negative, combining to a positive. So when we multiply to a negative, we need different signs. So different signs subtract. So which pair gives us a positive 10? 23, 10. So it's the minus 2 and the 12. Minus 2 plus 12. Those multiply to a negative 24, combined to a positive 10. Now in the second one, number 6, we're multiplying to a positive 24. So I'm going to switch this to a positive and make this a negative. So just like in the last one, whenever it's that form, minus plus, we have minus, minus. So now we have to change the signs, make sure everything is negative. Same sign, add, right? So now when I add across, we get negative 25, negative 14, which does not work, negative 11, and negative 10. So this time it's that bottom one. All right, so now we're going to move on to our third type of factoring. So multiply these out. Pause the video and do them. So we have x times x minus 9 plus 9 times x minus 9 is x squared minus 9x plus 9x minus 81. Notice that the two middle terms cancel out, and we get x squared minus 81. The second one, number 8, same idea. We take our 4x, we multiply by 4x minus 5, plus 5, 4x minus 5. Distribute 16x squared minus 20x plus 20x minus 25. And again, those middle terms cancel out. 16x squared minus 25. So in both of these cases, the middle term canceled. So why did it cancel? Well, if you notice, they are the exact same binomial with different signs. They are the exact same binomial. One's a plus, one's a minus, right? That's important. We're going to keep that in mind. So, and then look at our answer, 16x squared minus 25. Could we GCF that? No, nothing divides into 16 and 25. But what's something you notice about the binomials? Both of our answers are minus, right? They're both subtraction, and that comes because we had that plus and minus on the inside of the binomials, right? 4x plus 5, 4x minus 5, x plus 9, x minus 9. We always have opposite signs, so the second number will always be a negative. Right? So we have to have a subtraction. And then what kind of numbers are 16, 25, and 81? Do we know what those are? If you look down on your notes, you'll probably figure it out. Those are perfect squares. So whenever you have a perfect square minus a perfect square, that's going to be this method. All right, so let's write down what the perfect squares are. If you know them, write them on your own. 1 squared is 1 times 1, which is 1. 2 squared is 4. 3 times 3, 9. 4 times 4 is 16. 5 times 5 is 25. 36, 49, 64, 81, 100, 121, and 144. All right, so those are our perfect squares. I'm going to add one at the bottom that I think we should know. 15 squared is 225. So these are our perfect squares. We need to be able to recognize them. It's really important when you see 81, you think to yourself, oh, that's a perfect square. That's 9 times 9. All right, so now we're going to try to factor these. The first thing I do when I see a binomial is I think to myself, can I do a GCF? Well, if you look at all of these, you can't divide by anything. If you try dividing by x, you get craziness, right? First one, if I try to divide by x minus sad face, right? I can't divide that. So we have to recognize that this is a perfect square minus a perfect square, right? So that means I know it's x times x gives me x squared. 5 times 5 gives me 25. So it's the exact same thing with opposite signs. That's it. When I multiply those out, those middle two terms cancel out because it's the exact same thing with different signs. So what do you think number 10 is? Write down what you think your answer is. Again, x times x is x squared. 7 times 7 is 49. Make one of them plus, one of them minus. Now, order doesn't matter. You can do minus plus. I always do plus minus. It's just how I write it. All right, 11 and 12 are a little more difficult, but I have confidence in us because we are so smart. So what times itself is 100x squared? 10x times 10x is 100x squared. What times itself is 81? 9 times 9. Throw in a plus and a minus. All right, pause and do 12 on your own. What times itself is 4x squared, so that's 2x times 2x is 4x squared. 11 times 11 is 121. One's a plus, one's a minus. So I call this the dots factoring method. Dots stands for the difference of two perfect squares. Running out of space. So difference of two squares. I can't put the P in there. That would be dot. Doesn't quite work. So dots. Difference of two squares. We just have to assume they're perfect. Okay, so try number 13 and 14. Then we'll do 15 and 16 together because those are harder. All right, so these are a little trickier because they've got x's and y, but it's the same process. 64x squared. What times itself is 64x squared? 8x and 8x. 9y squared. 3y and 3y. Plus and minus. 14, not overly hard, but that 1 always messes kids up. What times itself is 1? 1 and 1. 25y squared is 5y and 5y. One's a plus, one's a minus. All right, so now we're getting into 15. 15 is the tricky one. All right, so again, we're going to start like that. I've got my 16, right? So that's a plus 4 minus 4. Here's the question. What times itself is x to the 4th? Gee, I wonder. What do we do to exponents when we multiply? We add them. So what adds to 4? What plus itself adds to 4? X squared and x squared. Now, here's the tricky part. We're actually not done. Now, x squared plus 4 is not subtraction, so you can't do anything there. So I'm going to leave it. However, look at x squared minus 4. That looks just like those other ones we were doing, so we can actually factor that again. X times x is x squared plus 2 minus 2. And like I said before, the plus one you can't do anything to. All right, last one. Now, this one throws kids off all the time. This is not a dots. This is not a difference of two squares. Why? This has an X right here. Because that has an X, this is not dots. Because what times itself is X? I've no idea. So this is actually a GCF. This is a GCF problem. Whenever you have X's everywhere, you have a GCF of X. Divide. So it looks like a dots because the 9 is perfect square, but it's not. All right, before we go to the last slide for the homework, I want you to draw me a happy face. All right, draw me a happy face next to number 16. All right, and that is it. I got some new memes for you. All right, have a fabulous day. I will see you later.